Hello and welcome, my students. Today's lectures we are going to discuss the new topic superconductivity. Now we are going to first points the discovery of the superconductivity. You know that generally the various metals it has the one or more valence electron in this outermost shell, and due to these electrons they can conduct the electricity. But you know that the electrical conductivity of the metals they will increasing the temperature with nonmetals as bad conductors of electricity. The elements like the boron, silicon, germanium, which are the semiconductors, their conductivity may be intermediate between the metals and non-metals. Superconductors has zero or almost zero electrical resistance. They may be carry the electric current without losing energy. In principle, current can flow forever. That is, the superconductors have the infinite number of the conductivity. The superconductivity began the name of the scientist. It is a Hike Karmer Ling Ons. He discovered the superconductivity in mercury in 1911. He found that in case of mercury with decrease in temperature, resistance will be decreased, and at a temperature of 4.2 Kelvin, the resistivity suddenly dropped to zero. And at this phase, the zero resistance state, and this phenomena is called as the superconductivity. The Cavons study by liquid helium, he observed that the properties of the substances which has the very low temperatures, the metals such as mercury, lead, tin, and indium, it has become superconductors at a temperature near absolute to zero. Later on, the Misner and Ocenfield found that some superconducting materials they will not allow the magnetic field to penetrate their bulk. That is, the superconductors completely excludes an external magnetic field, which is called as a Misner effect. In 1975, it is observed that the alloy of niobium germanium can act as superconductors at 23 Kelvin. In 1986, the George Bednorz and Alex Miller, which discovered some compounds like lanthanum copper oxide, in which the lanthanum is partially replaced by barium, and they shows superconductivity at 30 Kelvin. This discovery stimulated to interest in ceramic superconductors. The number of such compounds were then reported at a different laboratories by replacing the barium, calcium, strontium, substituting different lanthanides, varying the preparative conditions to control the amount of oxygens. And these Bednarz and Millers were awarded the Nobel Prize for this work in 1987. In early 1987, his co-workers report the compounds of the type, it is a yttrium beryllium copper oxide became superconducting at 93 Kelvin. This temperature was significant for a practical reasons. They allowed the liquid nitrogen can be used as coolant rather than the liquid helium, and such discoveries which produce research on high temperature superconductors, the perfect making superconductors which work at room temperature will continue to attract attentions. Technical applications have great the financial benefits in our life. The next points we are going to discuss what is the superconductivity. The phenomena of abrupt disappearance of electrical resistance at very low temperatures, which imparts the high electrical conductivity to conductors and making it superconductor, is called as a superconductivity. Means that it is a property of the metals by virtue of which they lose all electrical resistance and become perfectly diamagnetic below certain characteristic temperature, is called as a superconductivity transition temperature. This phenomena, which is exhibited by the materials which are very low temperatures, like the superconductors has very low temperature, they will be shown as superconductivity. It has the zero or almost zero electrical resistance, and hence they can carry electric current without losing energy. In this principle, the current can flow forever. The metals such as aluminium, copper, they are good conductors of electricity, but they do possess some electrical resistance. But when we use the metals as a electrical transmission cables, we observe that the electrical resistance can be decreased by decreasing the temperature and to make the material act as a superconductors. But however, practically, their use is not possible, and the metal transmission of electric power prohibitive cost of maintaining electrical cables. The superconductors, they are extremely high current can be passed through a very fine wire. You know that the very small coil in these electrical appliances can be used to make as a powerful high field electric magnet. And these superconductors has effectively zero resistance, and therefore such a coil does not become hot, means no current they will be lost. Superconductivity is related to applied magnetic field. It is also shows the magnetic property. But by using at a certain applied magnetic field, the superconductivity, it can be lost and substance become the normal conductors. In 1911, the scientist Cavans discovered a new phenomena as a superconductivity. For a long time, to study the conductivity experiment, that electrical resistance of the metal decreases with decrease in temperature. He was found that the resistance of the mercury decreases with decrease in temperature, and it falls to an extremely low value, almost zero resistivity at 4.15 Kelvin, and impart very high electrical conductance. Then it has been found that the number of metals, alloys, electrical resistance, they will be disappear and completely at a temperature few degree above absolute zero. And at very low temperatures, the pure mercury shows almost zero resistivity at or below 4.15 Kelvin and very high electrical. Some like by using the external applied minimum magnetic field which is necessary to destroy the superconductivity, and they can be restored at normal resistivity is called as the critical magnetic field. It is also two types. The one of the types we have see is here the superconductors having only one value of HC, means critical magnetic field, and this external applied magnetic field they will be increased and reach the value of HC, that is a critical magnetic field. The superconductivity is lost and substance returns to a normal state. Next points we have see the transition temperatures, or another name is critical temperatures. The temperature at which the material undergoes electrical conductivity, such a transitions is called as a superconducting transitions temperature or critical temperature. Means at a temperature in which the material undergo transfer electrical conductivity transitions, which is called superconducting transitions temperature or critical temperatures. It is a temperature below which a material shows zero resistance, denoted by Tc. The maximum temperature at which the some superconductors exhibit superconductivity is called as critical temperature. The material is superconducting when they offer no resistance or zero resistance by passage of electricity. The temperature decreases and therefore resistivity also decreases and conductivity is increases. By this phenomena, we shows at a certain temperature the resistance of the metal almost drop to zero and it enters into state of superconductors. This temperature, which is called as a transition temperature or the critical temperatures. But we know that electrical conductivity is related to critical temperatures. Means, so superconductivity transition temperature, which is denoted by Tc. This will affect on temperature in resistance, which is observed by H.K. Ons in 1911. He took up such a study in liquid helium. We have seen earlier the temperature at mercury, which is found to be decrease in temperature of resistance of mercury decreases at about 4.2 Kelvin, and it drops considerably so that it can act as a superconductor. The value of mercury resistance used was 172.7 ohms in liquid conditions at 0 degree centigrade. From this melting point minus 40 degree centigrade to 0 degree centigrade by means of temperature, the coefficient of solid mercury gives the resistance corresponding to this 39.7 ohms in solid state. So these various examples of superconductors are like the lutetium, hafnium, these elements which can be used as superconductors to make the compounds like niobium Li, niobium tannus, niobium germanium. So such compounds they will be prepared for these superconductors. For their transition temperatures, they will be like the titanium carbide is 1.15, niobium aluminum is a 17.5, niobium tannus is a 18.5, etc. But you know that the material is superconducting when they offer no resistance or zero resistance by passage of electricity. But maximum temperature at which superconductor they exhibit superconductivity, it is also called as a critical temperature. Those graph will be clearly show that how will you change this metal to their superconductors. Means at a temperature at which the material was converted to superconductors, means having a zero resistance, is called as a critical temperatures. Points also we have see that the temperature at which superconductivity is occur is called as superconducting transition temperature, and the material are said to be superconducting means they offer no resistance or the zero resistance. The superconductor has practically zero resistance and hence and carry electric current. The current induced in superconductor and they persist for years without hitting the conductors. It is also produce magnetic field of high strength. The temperature below transition temperature, the magnetic field they will be reach the value of Hc, means the critical temperatures.